divided by negative 3 to the first power. Remember, the negative exponent comes downstairs and becomes positive. So in the final analysis, we have 1/2 times negative 1/3, which is negative 1/6. So when I plugged in 0, I got negative 1/6, which was the first thing I'm going to add. Which means over here, when I plug in 1, I better get negative 1/6, because that needs to be the first thing I add from the yellow part. So the question is, how can I write this inner green over here so that when I plug in 1, I'll be getting negative 1/6? Well, so
is what you're doing right now, is that like applicable for any other problem?
any problem where we're starting with 0, yeah. And that's the only time you would use it. If you're starting with 1, just do it like number 40, straight to the formula. So this is, the 1/2 stays, the negative 3 stays, but this needs to be raised to a power so that I will get this answer. So k, so when I plug in 1 here, I better get negative 1 as the exponent, so k minus 2. Now when I plug in 1, 1 minus 2 is negative 1, so my answer is 1/2 times negative 3 to the negative 1. 1/2 times negative 3 to the negative 1. Questions on rewriting, and then I'll give you the general rule. So the general rule is as follows. General rule is we started with this. The intermediate step was this. And what we really did, folks, is we said, instead of having k here, I imagine this is k, we just put k minus 1. And then there happened to be another minus 1 there, so we put another minus 1. If there had only been a k here, then there would only have been a k minus 1 here. But because there was an additional minus 1 there, there is an additional minus 1 there. So anywhere you see the exponent when you're doing this rewriting, get rid of the k and put it as k minus 1. Of course, here you already had a minus 1, so you need to keep that minus 1 there. And of course, this, when you write it a little more cleanly, you get k minus 2. Because negative 1 minus 1 is negative 2. And that is what we had right there. Stop here and take questions. So again, this strategy is only needed when we're starting at 0, because when we start at 0, these formulae are not applicable. Now that we have this problem is virtually identical to number 40. So take 2 minutes on your own and try now to finish this yellow to get the answer. I'll be modeling on the board. So if you need to check, feel free to look up. Let's try this one on our own. And again, you're solving the yellow sigma. So make sure what I'm doing here is verifying whether this is geometric or arithmetic. Alright, so and again, if you need to verify that you're getting what I'm getting, please do that. So because of the negative 3 needs to go into parentheses, leave it up. Let me take some questions on this. Questions? Okay, so we'll take a 1-minute break and then we'll come back to you. Edgar.
When it is negative 3 to the 6 times and it's negative 7 to
The negative 3 should go in parentheses. Then you'll be good. Back together. And I want to go over some notes before we attack some of the next problems. So we have, we talked about a sequence, which is so sequence is just a group of numbers that follow a pattern or rule. Pattern or rule. Let me introduce a new term, series. The series refers to the sum of a sequence. So, like the first sum, the second sum, second partial sum, third partial sum, fourth partial sum, blah, blah, blah. When we are talking about series, I want to really focus on the infinite sum. And what do I mean by infinite sum? What I mean by that is when you take the sum of all of the terms. We take the sum of all the terms. Not the same as the partial sum. Remember we had talked about partial sums before. Remember, partial sums are just when you add up a portion of the terms. Now, every series either converges or diverges. Every series, if you want to think about it, series can converge, and if a series converges, that means that we approach a number. So that means, for our purposes, if the series converges, that means that we approach a number. So if I were to add up every single term, I would get really close to a number. This will make sense as we get an example. And a diverge, if a series diverges, then it approaches either positive or negative infinity. Positive or negative infinity. What I want to do now is leave a little space in your notes. I'm going to do some examples, then we'll come in, fill in some of these definitions. So let's start with an example. That'll be the first example. Second example. Okay. I think many of us are in a very good position to identify the type of sequence and then the value associated with it. And again, these are not on the sheet, not on the homework sheet. If I think about this, if I think about the infinite sum, so the sum of infinite terms, we'll call it the infinite sum. And for our purposes, you can think about that as when I'm talking about the series, that's what I'm talking about. So if I added up every single term here, so 1 plus 4 plus 7 plus 10 plus 13 plus 16 is the next term, 19, and so on and so on, I would get a number that keeps on getting bigger. And essentially, I would get positive infinity. So I can therefore say that this infinite sum, or this series, diverges. It diverges because if I add up all the terms, we approach infinity. Okay. Another thing that we often talk about